Welcome to today's deep dive. We're going to be taking a journey through the life cycle of stars.
Oh, exciting.
Yeah, and we'll be using the astronomical minute as our guide.
Excellent source.
So get ready to uncover all the secrets of these cosmic giants, from their birth to their spectacular demise.
And did you know we owe our very existence to stars?
Oh.
Yeah. The atoms that make up, well, you, me, the Earth, everything around us, were actually forged in the hearts of stars.
Okay, that's pretty mind-blowing. I'm definitely ready to unpack all of this. So
Wow.
where do we even begin? Where do stars even come from?
What all starts in these vast clouds of gas and dust
Huh?
called nebulae. Imagine like a cosmic nursery stretching for hundreds of light years,
Wow.
filled with the raw materials for star formation.
Nebulae, they sound absolutely massive. I'm picturing something like a giant cosmic cloud of smoke. Am I even close?
Yeah, that's a pretty good analogy. But instead of smoke, think of it as this swirling mix of hydrogen, helium, and tiny dust particles. Now, over millions of years, gravity starts to pull these particles together. It's like a slow-motion dance as clumps of matter start to form within the nebula.
Millions of years, huh? Space really does operate on a whole different time scale.
Hmm.
So how do we go from a clump of dust to a blazing star? What's the trigger?
Well, as those clumps grow denser and denser,
Mm-hmm.
the temperature at their core starts to rise dramatically.
Okay.
It's like squeezing a balloon.
Oh, yeah.
The more you squeeze, the hotter it gets. And eventually, the core reaches a scorching temperature of millions of degrees.
Okay, so I'm starting to get a sense of the immense forces at play here.
Yeah.
So what happens next? Does it just like burst into flames?
Not exactly flames, but something even more incredible: nuclear fusion.
Okay.
At these extreme temperatures and pressures, hydrogen atoms start to fuse together to form helium.
Huh.
This process releases a tremendous amount of energy, and that's what makes a star shine.
So this fusion process is like the engine that powers a star?
Precisely. It's the heart of a star, constantly converting matter into energy and sending that energy radiating out into space as light and heat.
Fascinating. So we've got this cloud of gas and dust.
Yeah.
Gravity pulls it together.
Yeah.
The core heats up and boom, nuclear fusion kicks in. A star is born.
That's the gist of it. And once that nuclear fusion ignites, the star enters what we call the main sequence.
The main sequence?
Yeah.
That sounds familiar. Isn't that where our sun is?
You got it. Our sun, like billions of other stars in our galaxy, is a main sequence star.
Cool.
It's in the prime of its life,
Okay.
steadily fusing hydrogen into helium and bathing our solar system in warmth. This phase is the longest and most stable period in a star's life.
So our sun is just vibing, doing its thing on the main sequence. I'm guessing not all main sequence stars are created equal, right? Some are bigger, some are smaller.
You're absolutely right. A star's mass,
Right.
which is determined during its formation in the nebula, plays a huge role in its characteristics and ultimately its fate.
Okay, so let's talk about different types of stars. What's the difference between, say, a small star and a massive star?
Well, think of it this way. A small star, like a red dwarf, is incredibly fuel efficient. They're like the economy cars of the cosmos.
Mm-hmm. Okay.
They burn their hydrogen slowly
Mm-hmm.
and can live for trillions of years.
Wow, that's a long time.
On the other hand, massive stars are like gas-guzzling SUVs.
Okay.
They burn hot and bright, but their lifespans are much shorter,
Okay.
perhaps only a few million years.
Trillions of years. Wow, that's almost impossible to comprehend. So red dwarfs are like the marathon runners of the universe,
Yeah.
while massive stars are more like sprinters.
That's a great way to put it. And it all comes down to their mass. Red dwarfs have much lower mass than massive stars,
Okay.
so their gravity is weaker. This means the pressure at their core is lower, and they fuse hydrogen at a much slower rate, making them incredibly long-lived.
That makes sense. So where does our sun fit into all of this? It's not a red dwarf,
Nope.
but it's not a massive star either, is it?
Exactly. Our sun falls somewhere in between.
Okay.
It's a medium-sized star with a life expectancy of about 10 billion years, and it's already about halfway through its main sequence lifetime.
Okay, so our sun is middle-aged, still happily fusing hydrogen into helium. But what happens when it starts running low on fuel? That's got to have some consequences, right?
That's when things start to get really interesting, and a star's fate takes a dramatic turn. We'll delve into that after a quick...
Hold on, don't leave us hanging. What happens to a star when it runs out of fuel? Is it a slow fade or a grand finale? I need to know.
All right, all right. You're right, this is where things get exciting. The end of a star's life is just as captivating as its beginning. And to understand what happens next, we need to look at the different paths stars take as they approach their twilight years.
Okay, now you've got me hooked. Let's dive into the final act of a star's life. I'm ready for some cosmic fireworks.
Get ready, because we're about to explore the spectacular ways stars meet their end, from quiet fades to explosive supernovae.
This is going to be epic.
And along the way, we'll uncover how these stellar deaths are not only destructive events, but also crucial for the creation of new stars, planets, and even life itself.
I can't wait to hear more. This is turning into a cosmic thriller. All right, so we left off with stars running out of their hydrogen fuel. What happens next?
Well, it really depends on the star's initial mass. Remember those fuel-efficient red dwarfs we talked about?
Yeah, the ones that can live for trillions of years.
Right. For them, the end is actually quite peaceful.
Oh,
Yeah.
oh.
As their hydrogen runs low, they gradually cool down and contract, eventually becoming what we call white dwarfs.
So it's kind of like a star fading into retirement.
Exactly. White dwarfs are incredibly dense, but they no longer produce energy through fusion. They just slowly radiate their remaining heat away over billions of years.
A slow fade into the cosmic night. Kind of poetic in a way. But what about those massive stars? The ones that live fast and die young. Their endings must be a bit more dramatic, right?
Oh yeah, you're absolutely right. Their grand finale is something truly spectacular. Remember how we talked about the cores of stars getting hotter and denser as they fuse heavier elements?
Yeah, and you were making it sound a bit ominous, like something was about to give.
Well, with massive stars, that's exactly what happens. Eventually, the core becomes so dense and hot that it can no longer support itself against the inward pull of gravity. It's at this point that the star's core collapses in on itself, triggering one of the most powerful explosions in the universe. A supernova.
A supernova. Okay, now we're talking cosmic fireworks. So what does a supernova actually look like? Is it just a big, bright flash?
It's much more than just a flash. Imagine a star suddenly blazing millions, even billions of times brighter than it normally is. This intense burst of light can briefly outshine an entire galaxy.
Wow, that's just mind-boggling. But there's got to be more to it than just a light show, right?
Hmm.
What else happens during a supernova?
During a supernova, the star expels its outer layers into space at incredible speeds. And this is where things get really interesting, because those expelled layers contain all sorts of heavy elements that were forged in the star's core during its lifetime.
Hold on, you're saying that the elements that make up planets and, us, were created inside stars and then scattered across the universe by supernovae.
That's exactly right. Elements like carbon, oxygen, iron, even gold and silver were all created through nuclear fusion in the hearts of stars. And without supernovae to spread these elements far and wide, our solar system wouldn't exist, and neither would we.
So in a sense, we're all made of stardust.
Exactly.
It's incredible to think that something as destructive as a supernova is also responsible for creating the building blocks of life.
It's a beautiful example of how the universe works in cycles. Destruction and creation are two sides of the same coin.
I like that.
Now, after a supernova, what's left behind depends on the mass of the original star.
Okay, so we've got these remnants of massive stars. What are they? What happens to them?
There are two main possibilities, and they're both pretty extreme: neutron stars and black holes.
Neutron stars and black holes, I always imagine those as like science fiction concepts, but they're real.
They are very real, and they're some of the most fascinating objects in the universe. Let's start with neutron stars. Imagine a star's core, many times the mass of our sun, compressed down to the size of a city.
A whole star crammed into a space the size of a city. That seems physically impossible.
Yeah.
How can something be that dense?
It's hard to wrap your head around, I know. But that's the power of a supernova.
Yeah.
It can crush matter to incredible densities.
Yeah.
In fact, a teaspoonful of neutron star material would weigh billions of tons.
Okay, that's just mind-blowing. What else makes neutron stars so special?
Well, some neutron stars spin incredibly fast, emitting beams of radiation that sweep across space like a lighthouse beacon.
Wow.
We call these pulsars, and they were actually the first neutron stars to be discovered.
Really?
Yeah. Astronomers initially thought they were signals from alien civilizations because of their precise, regular pulses.
Wow, so pulsars were almost mistaken for alien messages. That's amazing. But what about those other remnants you mentioned? Black holes. Those sound a bit more intimidating.
Black holes are definitely the most mysterious and awe-inspiring objects in the universe. They form when the core of a very massive star collapses to an infinitely small point, creating a region of space-time where gravity is so intense that nothing, not even light, can escape.
So they're like cosmic vacuum cleaners, just sucking up everything in their path.
It's not quite like a vacuum cleaner. It's more like a bottomless pit in the fabric of space-time. Anything that crosses the black hole's event horizon, the point of no return, is trapped forever.
Okay, that sounds a bit terrifying, but also incredibly cool. It makes you wonder what happens to things that fall into a black hole. Do they just get crushed into oblivion?
That's a question that has puzzled scientists for decades.
Mm.
We don't know for sure what happens inside a black hole, but we have some pretty mind-bending theories. It might be a singularity, a point of infinite density, where the laws of physics as we know them break down. Or it might lead to another universe, or even another dimension.
Ooh, another universe. Now, that's a thought-provoking concept. But how do we even know black holes exist if we can't see them?
We can't see black holes directly, but we could detect their presence through their effects on surrounding matter. For example, if a black hole is orbiting a star, we can observe the star's motion and see how it's being influenced by the black hole's intense gravity. We can also detect the radiation emitted by material as it falls into a black hole.
So even though they're invisible, black holes leave their mark on the universe.
Right.
They're like cosmic ghosts haunting the fabric of space-time.
That's a great way to put it. And it highlights the fact that even in death, stars continue to play a role in shaping the universe.
Mm-hmm.
Their remnants, whether white dwarfs, neutron stars, or black holes, continue to interact with their surroundings, influencing the evolution of galaxies and the formation of new stars and planets.
It's amazing to think that these objects, formed from the death throes of stars, can have such a profound impact on the universe.
It's a testament to the interconnectedness of everything in the cosmos. And it leads us to a deeper question. If stars are the building blocks of galaxies, and galaxies are the building blocks of the universe, what does that say about our place in this grand cosmic scheme?
Wow, that's a pretty profound question. So where do we go from here? How do we even begin to answer that?
Well, I think the first step is to appreciate the incredible journey we've taken so far. From the birth of stars and vast nebulae to their spectacular deaths and the formation of these mind-boggling remnants.
You're right. It's been an incredible journey through the life cycle of stars, but I have a feeling this is just the beginning of our exploration.
It certainly is. And there's so much more to discover about the universe and our place in it. But perhaps the most important lesson we can take away from all of this is that we are not separate from the cosmos. We are a part of it.
Yeah,
We are, as Carl Sagan famously said, star stuff.
we are star stuff. It's both humbling and awe-inspiring to think about it that way, and it makes me want to learn more, to keep exploring and asking questions about the universe and our place within it.
That's the beauty of science, and of astronomy in particular. It's a journey of discovery that never ends. There are always new mysteries to unravel, new wonders to explore, and new insights to gain.
All right, I'm ready for the next chapter of this cosmic adventure. What else can you tell us about the amazing world of stars? You know, we've covered a lot of ground in our deep dive today. We've explored the science behind stars, from their fiery births to their spectacular deaths.
We've learned how these celestial giants shape the universe, creating the elements that make up everything around us, including ourselves.
Yeah, it's been a truly awe-inspiring journey. But there's another layer to this story, isn't there? It's not just about the science. It's about how stars have, like, captivated human imagination for centuries.
Absolutely. For millennia, humans have looked up at the stars and wondered about their place in the cosmos. Stars have been woven into our myths, our religions, our art, and our literature.
Yeah. Think about ancient civilizations using stars for navigation, creating constellations, telling stories about the heroes and gods they saw in the patterns of the night sky.
It's fascinating how stars have served as both a practical tool and a source of inspiration throughout human history.
Yeah, it's almost as if they provide a cosmic map, not just for navigating the physical world, but also for navigating our own thoughts and beliefs.
Exactly. And if we connect this to the bigger picture, it raises a profound question that we touched on earlier. If we are truly star stuff, as Carl Sagan said, what does that say about our place in this vast universe?
It's a question that has haunted philosophers and scientists for centuries, right? Are we just tiny specks of dust in an indifferent cosmos? Or do we play a more significant role in the grand scheme of things?
It's a question without a definitive answer. But I think exploring the life cycle of stars offers some clues. It shows us that we are not separate from the universe. We are an integral part of its story.
We're born from the same cosmic material, shaped by the same forces, and ultimately destined to return to the stardust from which we came.
It's a beautiful and humbling realization that connects us to something much greater than ourselves.
It also makes me think about the future. If stars are constantly being born and dying, what does that mean for the future of our own sun, our solar system, and ultimately for us.
That's a great question. And it's one that astronomers are actively studying. We know that our sun has about 5 billion years left in its main sequence lifetime. After that, it will expand into a red giant, engulfing the inner planets, including Earth.
Whoa, that's a pretty dramatic end for our planet.
Yeah,
But it's billions of years in the future, so we have some time to figure things out.
indeed. And who knows what technological advancements await us in that time. We might find ways to travel to other star systems or even engineer new worlds to inhabit.
The possibilities are endless when we consider the vastness of time and space. It's both exciting and a little daunting.
Absolutely. And it underscores the importance of continuing to explore the universe, to push the boundaries of our knowledge and understanding.
So, for all our listeners out there, as you go about your day, remember this. The next time you look up at the night sky, don't just see twinkling points of light.
See the echoes of ancient supernovae, the birthplaces of new stars, the swirling remnants of nebula where the raw materials of the universe are being forged.
See the grand tapestry of cosmic evolution unfolding before your eyes, a story that we are all a part of.
And remember that you, yes, you are made of stardust. You are a child of the universe, connected to every other star and galaxy in ways we are only beginning to understand.
And that's a wrap on our deep dive into the lives of stars. We hope you've enjoyed this cosmic adventure as much as we have.
Keep looking up, keep asking questions, and keep exploring the wonders of the universe. Who knows what amazing discoveries await us in the vast expanse of space and time?